Section P.3 is regarding polynomials and special products. This first video just focuses on polynomials. So what is a polynomial? It is any combination of numbers and variables separated by addition or subtraction signs. For example, 4x squared minus 5x to the 7th minus 2 plus 3x is considered a polynomial. And it's called a polynomial function because all of our exponents are whole values, whole numbers, meaning 0, 1, 2, 3, etc. For this function to be in standard form, we need to write the polynomial in descending order according to the variables. So for this to be in standard form, we would write it as negative 5x to the 7th plus 4x squared plus 3x minus 2. The number in front of the highest power is always called your leading coefficient. We're going to abbreviate that from now forward in math. The leading coefficient is negative 5, and the degree is always the highest exponent. So in this case, the degree of this polynomial is 7. And here are some more examples. This example A is called a trinomial. It has a specific name. It's called a trinomial because it has 3 pieces, or 3 terms in it. To get it in standard form, we would write it as x squared minus x plus 3. Its leading coefficient is 1, and its degree is 2. For the next one, this is really just, it would be like you're seeing the equation y equals 7. That actually is also a polynomial. It's just that this polynomial only has a constant term. So it doesn't really have a leading coefficient because it doesn't have a variable in it. And its degree would technically be to the 0 power because this would be this. I could write this. I could add on a plus x to the 0 power. Actually, no, we can't do that. I meant multiply. I meant multiply by x to the 0 power. Sorry, because multiplying by x to the 0 power is the same thing as multiplying by 1, which would not change the value of this equation. So this one is just called a constant polynomial, and it has a value of 7, and that's all you would need to write. And to add polynomials, you actually just go ahead and, this is something you should have done probably extensively at the Algebra 1 level, but you just need to add together the like terms. And when you're adding those like terms, we don't touch the exponents. We just add together their coefficients. I'm going to take the step on this one of just writing everything out. Because of the subtraction sign around the second parentheses, we're going to have to distribute that. So this is going to become minus 3x to the 4th plus 4x squared and minus 3x. And then we just add our like terms. So we have 7x to the 4th minus 3x to the 4th, which is going to give us 4x to the 4th. We have a negative x squared plus a positive 4x squared, which leaves us plus 3x squared. We have negative 4x and negative 3x, which is minus 7x, and then a plus 2. And then the next piece, the last piece here, is to multiply polynomials. You've done multiplication of polynomials using the FOIL method when you took a binomial times a binomial, or 2 pieces times 2 pieces. We're going to do just one practice one here of multiplying a trinomial times a trinomial. So to multiply a trinomial by a trinomial, we're going to apply the same idea as foiling with the binomials. What we need to do is take the first piece distribute it to all the pieces in the second parentheses. You could do this the other way around if you could distribute from the second into the first. By the time you're done multiplying these, you should have 9 pieces because we're taking a trinomial times a trinomial. You should have 9 pieces that will have to be gathered with their like terms. So 2x squared times 3x squared. This is the case where we do have to touch the exponents. We need to when we multiply those, the exponents add up to 6x to the 4th. And then 2x squared times x is 2x to the 3rd. 2x squared times 4 is 8x squared. And by the way, you could write these either in a horizontal format or in a vertical format. Just keep writing it all the way across left to right. Or if you prefer, you can line up your variables in a vertical format. So next, I'm going to take the negative x from the first parentheses to multiply it by all the parts of the second. And then same idea, except you'll have to multiply the 3 into the second set of parentheses. So negative x times 3x squared is minus 3x to the third. Negative x times x is minus x squared. And negative x times 4 is minus 4x. And then we're going to distribute the 3 into all of them. So 3 times 3x squared is 9x squared. 3 times x is 3x. I'm going to run out of room here, so then the last piece is 3 times 4, which is 12. And then we need to gather like terms again together. And on these, I usually recommend to you that you cross them out as you go, because it's easy on this to just skip one little tiny piece, and then you wouldn't have your answer completely correct. So there's only one piece that's to the fourth power, so 6x to the fourth. With the cubes, I have 2x to the third and minus 3x to the third, so that's negative x cubed. 8x squared minus x squared is 7x squared, plus 9x squared is 16x squared. And then we have a negative 4x plus 3x, so minus x, and then our plus 12 is the last piece to bring down. And that's how you go about multiplying a trinomial times a trinomial. The next lesson will show you how to do this, how to multiply quantities squared, quantities cubed, etc.